Now that we know that the area between two curves can be represented as the integral from a to b of the top function minus the bottom function, if we're going to actually solve these problems, there's two mini questions that we have to answer. The first question is, well, what are the bounds? Okay. Now, sometimes, if you're lucky, the bounds are going to be given to you. Okay. And if that's the case, awesome, right? You know where to begin, what is A, and you know where to end, what's B. Sometimes the boundaries are not given to you, but instead, they're actually are given to you. They're just given to you as a graph. Okay. So if you're given a graph and the clearly marked points where the two functions intersect or where we're beginning and where we're ending, then you're good to go as well. So technically they're given to you, but it's just given to you in a geometric point of view. Right? Another possibility is that the bounds are not given to you. However, you do have your graphing calculator available to you. And if that's the case, you'll notice that on the TI calculator, if you enter in the two functions, in y1 and y2, or y2 and y3, whatever works for you, and you hit second trace, the second trace command pulls up the calculate menu for graphing, and one of the options, option number 5, is to find the intersection of two functions. And you can use that command. All right, so second trace, option 5 will get you where the bounds are. You just have to let the calculator determine where the two functions intersect. That's often used by the AP writers when they are coming up with questions and they're putting a question like this on the graphing calculator active part of the exam. However, we also want to be prepared for the situation where the bounds are not given to us and there's no graph and there's no graphing calculator as well. How do we go about finding the bounds in that regard? Okay, specifically we're looking at like example 6 right here, where one function is x and the other one is x squared. Where do the bounds happen to be if we're looking for the area between those two curves? The answer is that you're going to set the two functions equal to each other. All right, so you're going to set f and g equal to each other. All right, and solve. All right, so you're going to have to use your algebra skills. Okay, we set the two functions equal to each other. Quite often that means that there's going to be some kind of quadratic involved. And therefore, we're going to get all the values onto one side of the equation and then solve that quadratic. So let's do a nice, easy example. Example number 6. We see f of x equal to x and g of x equal to x squared. We want to find the bounds of the region in between those two functions. Now, you might look at something this simple and say, oh, I know what the answers are. And that's great. And if you can find the answers and verify that they are correct, great. But if not, here is the actual process. Okay. So for starters, we're going to set the two functions equal to each other. So we have x is equal to x squared. And now we have to solve that equation. Okay. Well, whenever we have a quadratic and we're trying to solve it, you have all these different options. Quadratic formula is one of them. In a situation like this where the two terms are not all that hard though, and regardless, we really want to get the quadratic equal to 0. So let's get the x over to the other side. So we have x squared minus x is equal to 0. We're going to subtract x from both sides, giving us that situation. Now we can factor that binomial right there. X squared and x, what do they have in common? An x term. So we're going to factor that out, leaving us with x minus 1. X squared divided by x is x. X divided by x is 1. And now we have ourselves a product which is equal to 0, which we like because we know that the zero product law tells us that either the first term has to be 0 or the second term has to be 0. So we cover them up one at a time. And we can see that x is 0. That's one answer. And the other answer is that x could be 1. So there are two answers there. Our 2 points of intersection are 0 and 1. And again, we found them by setting the two functions equal to each other and then solving that equation.